In this video, we discuss AC circuit analysis. AC means sinusoid. We follow 3 steps in the AC analysis. The first step is transform the circuit into the phasor domain or frequency domain. And second, we apply the strategy that we applied in DC circuit, KCL, KVL, nodal analysis, mesh analysis, and all the techniques we learned so far can be extended to the phasor domain. After we solve that in frequency domain, we can transferring the result back into the time domain. Let's look at an example of nodal analysis. In nodal analysis, the same principle in the DC circuit apply to the frequency domain or phasor domain. So first of all, we transfer everything in phasor domain. Here, everything is already in phasor domain. Here, that's the current source, voltage source, impedance, 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 and impedance. And we follow the same strategy. First of all, we define a reference node here, and then we apply the nodal voltage. There are 2 nodes here, V1 and V2. And then we apply the KCL on each node. In this case here, there is a voltage source involved. We need to form a super node here. Then we will have V1 minus V2 equals to 10, 45 degrees. Everything here is complex. And then we apply the KCL on this supernode. Everything flow into equals to everything flow out to. The current flow into, that's 3, 0. That equals to V1 divided by 3J plus V2 divided by J6, and then plus V2 divided by 12. So there are 2 equations and 2 unknowns. We can use MATLAB to help us to solve V1 and V2. V1 and V2 are complex. They're all complex numbers. So this is a nodal analysis in frequency domain. Mesh analysis apply to the frequency domain as well. In this case, there are 4 mesh, I1, I2, I3, and I4. And note there is a current source involved, so we need to form a super mesh. Total, there will be 4 equations, and we solve 4 unknowns. We can solve this circuit. The superposition theorem can also be applied in the phasor domain for AC circuit. The only catch is to pay attention to different frequencies on different sources. So for different frequencies, the impedance needs to be calculated again regarding to the frequency specified for that source. In source transformation is also applied for the AC circuit in the phasor domain. So everything we discuss is in the phasor domain. This is the voltage source in series of impedance. This is equivalent to a current source in parallel of the same impedance. The value of Ix equals Vs divided by Zs. Deafening theorem and Norton theorem apply to the phasor domain as well. Any linear circuit which involves sinusoid can be equivalently simplified to a current source in parallel of an impedance Zh equal to Z of n and Vth equal to Z of n multiplied by I of n. This is a Norton circuit. For the deafening circuit, we can use the source transformation here. This is an equivalent circuit for deafening theorem, Zth in series of Vth. Note these are equivalent for the same terminal A and B. Either this way or this way. Both are valid.